And now to jump into the middle of this playlist, Professor Sargent here with you again. And I'm going to add in some examples where we're graphing exponential functions using transformations, as well as take a look at an application of an exponential function. So here we go. We're going to graph f of x equals 4 to the x minus 2. I want you to notice that the minus 2 is after we have plugged in x to, plug in x into 4 to the x. So we're already getting y values, and the minus 2 is going to create a vertical shift down 2 units. All you have to do to get the graph of y equals 4 to the x, as shown in an earlier video, is plug in these 3 special values of x. The computations are pretty straightforward. 4 to the negative 1 is the same as the reciprocal of 4. So if we subtract 4 from each of those, here's what we have. Of course, you could write 1/4 as 0.25, so that when you're subtracting 2 from that, you would get negative 1.75. And here are the other two. So the points that we're going to graph are negative 1, comma, negative 1 3/4, 0, negative 1, and 1, 2. To see what that looks like, here we go. Here are those 3 points graphed. And the graph should look similar to the graph of y equals 4 to the x, which it does. We would have arrows at either end telling us that the domain is going to be all real numbers. And because of the shift down 2 units, that takes the horizontal asymptote y equals 0 and pushes it down to y equals negative 2. That's going to change the range. Instead of starting at 0 and going above, it's going to start at negative 2. So our domain, all real numbers written in interval notation. Our range, put that in interval notation. It starts at negative 2, but does not include it. It does not actually touch. And y equals negative 2, I already indicated, would be the equation of the horizontal asymptote.